A single steel bar locks the wheels down with a satisfying thunk. No computers, no circuits, just your arm and a piece of metal connecting you directly to the fate of the aircraft. Modern electric motors promise convenience, but every new wire and switch is one more hidden chance for failure when you least expect it. For pilots who have lived both worlds, the question is not nostalgia, it is survival. The difference between trusting a bulb and feeling the gear engage could cost you more than just a repair bill. So why did aviation trade a human sense of certainty for automation's silent gamble? Let us break down what really keeps you safe in the air. Reach down between the seats of a classic Mooney and your hand closes around a steel lever, the Johnson bar. This is not just a handle, it is the first link in a chain that runs straight from your arm to the landing gear. The path is as direct as it gets, a solid bar anchored on a pivot under the floor, connected by push-pull tubes and bell cranks to the main gear legs. Every motion you make is transferred, unfiltered, all the way to the wheels. There is no motor humming in the belly, no relay waiting to click, just metal, moving metal. The heart of the system is the over-center latch. When you throw the bar down for landing, you feel a rising resistance as the gear swings into place. Then, with a final snap, the bar locks over center and drops into a detent on the floor. That is not just a click, it is a mechanical promise. The geometry of the linkage means that once the bar is latched, the gear cannot fold back up without a deliberate pull. There is a downlock spring or bungee depending on the model, adding a final preload to keep everything tight. From the cockpit, you can trace the entire system in your mind. Lever, pivot, tube, bell crank, trunnion. No hidden circuits, no buried actuators. If you ever wonder what is happening, you can look, reach, and touch each joint. The total part count is low, just enough to do the job, nothing extra to fail in silence. Every joint is visible, every movement is audible and tactile. When the bar is down and locked, you know it because you did it yourself. The floor vibrates with the thunk, the latch holds steady, and the gear is either down or it is not. No in between, no mystery. This is mechanical honesty. The Johnson bar does not ask for trust. It demands participation. The effort is not just a workout for your arm, it is a feedback loop. If something is stiff, you feel it. If the bar will not go all the way, you know instantly that something is wrong. There is no guessing, no waiting for a green light. The entire linkage is a conversation between you and the airplane, and every flight, that conversation starts with a single, solid throw. Al Mooney didn't build airplanes for the faint of heart. He built them to go fast, run lean, and keep the pilot in command. In the 1950s, every ounce mattered. Hydraulic pumps and electric motors were heavy, complicated, and expensive to fix. So Mooney's answer was the Johnson bar, a direct mechanical link from cockpit to wheels that cut pounds and complexity out of the airplane. The sales brochures of the day bragged about the weight savings. Less weight meant more speed, and more speed was the Mooney calling card. The manual gear wasn't just a throwback. It was a calculated decision to keep the airplane light and honest. Operating the Johnson bar is a learned skill. It is not just a matter of pulling a handle, it is a full body motion. You reach down, grip the steel, and drive it through a long arc. There is a moment where the load builds, and if you are above the gear extension speed, the aerodynamic forces fight you. That is the airplane's way of telling you to slow down. It is not a warning light or a buzzer, it is physics, right in your hand. If you try to muscle the bar at 100 knots, you will feel the resistance and back off. Only when you are in the right envelope does the motion turn smooth and the bar snaps into its detent with a satisfying clunk. That is your confirmation, you did it right, and the gear agrees. Mooney's manuals and pilot training guides from the era spell it out. Proper technique is everything. The bar requires a quick, athletic throw, not a slow push. It is a move you practice until it becomes second nature. Some pilots call it a workout, others call it a ritual. Either way, it is a moment of connection. Your arm, the bar, the gear legs, all moving as one. There is no ambiguity. If something feels off, you know it instantly. If the bar won't go, you are either too fast, out of rig, or something is in the way. The feedback is immediate and unmistakable. This wasn't nostalgia or stubbornness. It was engineering for people who wanted to know exactly what their airplane was doing. The Johnson bar didn't just save weight, it put the pilot in the loop. Every movement, every ounce of force is a direct conversation with the machine. That is not something you get from a plastic toggle or a row of indicator lights. It is the kind of certainty that only comes from steel, sweat, and a design that trusts the pilot to do the job right. Electric landing gear systems promise ease. You flip a switch, wait for the motor, and watch for a green light. But beneath that simple act lies a web of vulnerable parts, each one a potential point of failure. Inside the belly of a typical electric gear airplane, you will find an electric motor, a hydraulic power pack, a tangle of relays, circuit breakers, and a line of microswitches that decide when the gear stops moving. Each of those components has its own job and its own way of quitting, sometimes quietly, sometimes with a bang. Start with the power pack. In models like the Cessna 210 and Piper Arrow, the power pack is a compact bundle of electric motor, hydraulic pump, reservoir, and sometimes a pressure switch, all crammed into a single housing. If the motor seizes, nothing moves. If the pump leaks, you lose pressure and the gear hangs in limbo. FAA service. Difficulty reports and airworthiness directives keep showing up for these parts. Cracked reservoirs, worn brushes, leaking seals, and check valves that stick open are common. One failed O-ring and the fluid ends up in the bilge instead of the actuators. Shops routinely see overhaul invoices in the $3,000 to $7,000 range just for this one bot. The wiring is the next hidden risk. The wiring harness snakes through the fuselage, connecting to relays that route power and to breakers that protect against shorts. Any corroded connector, chafed wire, or loose ground can break the chain. Circuit breakers trip for reasons that are not always obvious, sometimes from a real fault, sometimes just from age and vibration. When that happens in flight, the pilot faces a silent panel and a gear handle that does nothing. Micro switches and limit switches are how the system knows when to stop. If a switch drifts out of adjustment, the gear might stop halfway. If it fails closed, the motor can keep running until something strips or a breaker pops. It is not rare to find a gear leg hanging after landing, all because a switch sent the wrong signal. Piper and Cessna both issued service bulletins and airworthiness directives about these switches, which can be misadjusted, worn, or simply dead after decades of use. Relays are another hidden weak link. These small boxes take the pilot command and send current to the motor. A sticky relay can leave the gear stuck in transit, or worse, trigger an uncommanded movement. In some models, a single failed relay means the gear will not move, period. Add to that the mechanical side, actuators, uplocks, downlocks, and pivot points. Electric motors can mask a stiff or binding joint until the system stalls or something breaks. By the time a pilot realizes there is a problem, the gear might be jammed halfway, the breaker popped, and the checklist out. Diagnosing which part failed often means guessing at invisible electrons and hidden mechanisms while still flying the airplane. Every one of these components, motor, pump, relay, breaker, switch, wire, has its own service life, its own quirks, and its own price tag. The more parts in the chain, the more ways for the chain to snap. In a Johnson bar system, you can see and touch every joint. With electric gear, most of the risk is hidden until something stops working. That is the cost of complexity, convenience up front, and a long list of maybes lurking under the floorboards. Picture yourself low on final approach, engine coughing, runway rushing up. You reach for the gear. In a Johnson bar Moonie, that is a single, deliberate swing, 1 second, maybe 2 seconds, and the wheels are locked. The bar drops into its detent with a jolt you feel in your bones. That is it. No waiting, no hoping. The entire cycle is as quick as your right arm and as certain as the laws of physics. certainty. Now take the same scenario in an electric gear airplane. You flip the switch and wait. The motor spools up, the hydraulic pump whirs, and you count off the seconds. 1, 2, 3. By the time you reach 10, you are still watching for 3 green. That is normal. Most pilots' operating handbooks for single-engine airplanes with electric gear list extension times in the 8 to 12 second range, sometimes longer if the system is tired or cold. If the motor is slow or the pump is sticky, you might be staring at the panel, heart pounding, as the runway gets closer and the gear is not down yet. If the electric system fails, things get slow and complicated in a hurry. Emergency extension is not a single motion. It is a checklist: find the handle, remove a panel, crank dozens of turns, or pump a lever. In real-world training, emergency extension often takes 20, 30, even 40 seconds, and that is with a pilot who has practiced. Add in the panic of an engine out or smoke in the cockpit, and those seconds stretch into eternity. Every move eats into your margin. At a descent of 500 feet per minute, you lose more than 8 feet of altitude for every second spent fumbling with the gear. There is no stopwatch in the cockpit, but the numbers are real. A Johnson bar thrown at the right speed is as fast as your reflexes, over and done before the adrenaline even hits. Electric gear is a waiting game, and if the system quits, you are suddenly in a race against gravity and your own memory of the emergency checklist. In the time it takes to run the manual crank, you could have cycled the Johnson bar a dozen times. This is not just theory. Ferry pilots and instructors know that in time, critical emergencies, engine out, fire, forced landing, the difference between a 1-second throw and a 10-second wait can decide whether you make the field or end up short. The Johnson bar does not give you more skill or luck, but it hands you back those precious seconds when everything else is going wrong. When the only thing between you and the ground is what you can do right now, speed is not a luxury. It is survival, and that is why, in the worst moments, the old manual bar still earns its keep. You can't fake what the Johnson bar tells you. Every ounce of force in your right arm is part of a feedback loop that no electric switch can match. When you reach for that lever, you're not just flipping a command, you're reading the airplane's mind through your own muscles. The resistance isn't theoretical, it's real, and it changes with every knot of airspeed and every bit of drag on the gear doors. If you're too fast, the bar pushes back, warning you in a language you can't ignore. There is no guessing, no waiting for a green light to flicker on. Your body picks up a change in force as small as 5 or 10%. That's all it takes for you to notice something's off, maybe a little extra stiffness, maybe a sudden stop halfway through the throw. You feel it before you see it. That's the edge. If there's mud or ice in the wells, the bar hits a wall, not a breaker. You know immediately whether it's just high airspeed or a jammed leg. You can back off, try again, or decide to land with the gear up if you have to. The answer is in your hand, not buried in a checklist or hidden behind a panel. That's why pilots who fly these airplanes trust the bar. It's a direct sensory channel: your arm, the bar, the gear. No black box, no mystery, just you and the machine working it out in real time. Every flight, you get a mechanical conversation that electric systems can't deliver. And when something is wrong, you are the first to know, not the last. Open a mechanic's invoice for a 1970s Mooney with electric gear, and you will see the story in black and white. Power pack overhaul, $4,200. Add in a couple of relays, a limit switch, maybe a few hours of troubleshooting a dead green light. Suddenly, the bill creeps towards $7,000. That is not every year, but it only takes one surprise to wipe out the savings from a decade of routine annuals. Electric gear is a gamble. Most years it is just checks and lubrication, but when it fails big. Manual gear Mooneys tell a different tale. The typical repair ticket is a few $100s for new pucks, a bungee, or a round of grease. Maybe $1,000 or $2,000 if you do it all at once. No power pack, no hydraulic lines, no hunt for a decades-old actuator. The parts are simple, the labor is straightforward, and the work can be planned into the annual inspection. That predictability means owners know what is coming. There is no mystery bill lurking under the floorboards. That predictability has started to shape the used market. There is a steady set of buyers who look past the shiny panels and ask one question: does it have the Johnson bar? They are not chasing nostalgia, they are dodging $5,000 surprises. For them, a manual gear Mooney is not just an airplane, it is a hedge against the unknown. The numbers do not lie. Fewer failure points mean fewer chances for your wallet to take a hit. In an era where automation quietly multiplies hidden failure points, mechanical feedback is rare and valuable. Today's pilots still face emergencies where seconds and certainty matter. For all our advances, the simplest solution can offer the surest control. In the cockpit and beyond, sometimes the safest choice is still the one you feel in your own hands. Share your take in the comments below.